Hello everyone, and welcome to the second video for 12.2 ellipses. We're going to be working on this third example, but first I'd like to go back to the previous example to point out a few things to you. I would like you to notice again that from the center, the distance from the center to any vertex in either direction is the same distance, and also from the center to the focus and center to this focus must be the same distance, because this little distance is C and that bigger distance is A. The reason I mention that is if we need to work backwards and find an equation, let's first mark on this picture what we know. And even if you don't have a graph, I would suggest always drawing a picture, because I know some of you, like myself, are visual learners. So this tells me that I have two foci at 0, 0 and 4, 0. Now, I know that the center has to be directly between the foci. So that means that my center must be at 2, 0, and that will come into play later. Now, a couple of these things I wrote during the break between the two videos to help me organize my thoughts here. So first, we need to find, or just from the picture, we actually know the distance from the center to the foci. Now that is defined as C, but if I look at my picture, the distance from the center to the foci in both directions is 2. So my C value must be 2. The problem also tells me that the major axis is of length 8, and the major axis has to do with A. And so if you think about it, the major axis, if I again go back to the previous picture, the major axis is this entire length. So in this example, this entire length is 1, 2, 3, 4, 5, 6 units. And that makes sense because my A value was originally 3, or half of the entire axis. If I know that my entire axis is 8, that means that the distance of A from the center to a major vertex, or major vertex, is 4 units. So that means on my picture, from the center, if I go 1, 2, 3, 4 this direction, and from the green, 1, 2, 3, 4 this direction, I at least have a visual here that the green is my center, and these other points are my vertices and foci. Now I could continue drawing this picture, but the good news is that we can find a lot of this algebraically. Because I have A and B, or A and C, I bet I can find the B value. The reason that matters is because if I would like to find an equation, I need to either, again, excuse my jumping around, but I either need to think about this equation here or this equation here. If I look back, I need to decide if my ellipse is horizontal or vertically based. So if I go back to this third example, because my center, my foci, and these two major vertices here are all on the x-axis, this must be an ellipse that's x-based. So my general equation is going to look like this, with the A term underneath, or the larger term underneath the x. So let me write that here. Here's my general equation. Over A squared plus y minus k squared over b squared equals 1. And so what I could do is plug in what I know. I know A, so I could plug that in. I know the center, so I could plug that in. But first, let's find the B. And from previous examples, I know that if an ellipse is plus, my Pythagorean relationship is going to be minus. So my C squared, or 4, is going to equal A squared, which would be 16 minus B squared. If I subtract the 16 over, I would get negative 12 equals negative B squared. So that means that B squared equals 12. And actually, the good news is I could figure out that B is the square root of 12, but I don't need that because I'm trying to find the equation. So I can replace B squared with 12, and I can replace A squared with 16. So I would have A squared really being 4 squared, or 16. I would have B squared being 12. I know that all of this equals 1. But the top, the center, is 2, 0. So I would have x minus 2 squared, and the x has to be by the bigger number because it's horizontally based. And because my y coordinate is 0, you could write y minus 0 squared, but I think it's easier just to write y squared. So this would be my equation backwards. Feel free to go back and watch this example again, because I know for at least myself as a student, working backwards was always the hardest part, and we will be doing more practice examples in class. All right, guys, thanks for watching this 5-minute video. Good luck with ellipses.